Okay guys, just going to quickly make these notes because of the lesson we're missing next week. I'm just going to briefly go over the basics of what you need to know. So, the linear regression is just another word for line of best fit. Except this is literally the best possible line. I'm not going to go too much into the theory now, but essentially we want to create a line of this form such that if you had some x's, these distances are as small as possible. That's what would make it the best possible line. So of all the different lines of best fit you could draw by hand, the one that reduces the distance between the line and all the points is a line of best fit. Now you don't have to worry about how that happens, that's just the theory of it. You'll be given this, you won't have to calculate it. So, for example, if we had a context where we had an exam mark and we had time revising, very pertinent for what you're doing at the moment in hours, exam mark, let's call that percentage, and we had a pattern like this. And let's say for argument's sake, that was a line of best fit. And now let's say we call that y, we call that x. Y was equal to 20 plus 3x. All you need to be able to do is to interpret these parameters. In other words, the y-intercept and the gradient. So let's start with the y-intercept. So the y-intercept, which is here, that would literally be, in this context, the mark achieved with no revision. In this context. For any other context, obviously, you'd have to interpret it. This 3 is the gradient. So what that would mean is that we generally predict, now this is where you've got to pay attention to the units, that we predict a 3% increase per hour revising. It gives you a rate, essentially, okay? That's what you need to know. Now I'm going to use the notes on the other page to give you some more stuff here. So also, let's just do another example, okay? Let's just say, the line of best fit did something like that, y and x. Let's say that y was equal to 80 minus 2.5x. Let's say y was your exam score and x was, I don't know, time on social media. Time on TikTok. You guys keep talking about TikTok. Then this would say that 80% is the score predicted if no time spent on TikTok. And the minus 2.5 would mean, that's negative, so that would mean you go down or lose or decrease. So let's use the word decrease. Your score decreases by 2.5% for each. Now I should have put units here, percentage, let's call that hour again, for each hour spent on TikTok. So hopefully that second example you're getting the idea. Now the other thing I'll mention now is the issue with this, the potential limitation we should say is that we have extrapolated. And therefore, result could be unreliable. Okay? Because our data point went to here. But we're predicting outside the data. In the same way, if I try to work out how much time would you spend on TikTok until you lost your mind and got 0 on the exam, I could predict that. There could be a time X, but that would be extrapolation. If I asked one of you, let's say I asked, I don't know, Bilal, how much time you spent on TikTok, and he said, I spent 15 hours. Or let's call it 1.5 hours, that's not really too mean. And we could read off there. That would be interpolation. And that you assume to be fairly accurate because it's within the data set. Okay. So they're all the bits of theory you need to know for the end of your exam. And we'll pick up on this after your examinations.